Very good morning to everyone. So students, today we are discussing a very important mechanism in terms of annual board concern for your PUC annual examination. So which comes in the topic that is carbonyl compounds, that is aldehydes, ketones and carboxylic acid. So we are discussing addition of HCN to carbonyl compounds. Here carbonyl compounds means either you can take aldehyde or ketone. As you already know, aldehydes and ketones, they typically undergo nucleophilic addition reaction, not nucleophilic substitution. They undergo nucleophilic addition reaction. So typically the carbon oxygen bond, that is carbonyl carbon bond, is polarized due to more electronegativity of oxygen. Means you already know here the carbon atom develops partial positive charge and oxygen atom will develop partial negative charge. So due to this effect, let us take this A and this is B group. The nucleophile Nu minus will attack this carbon atom, and to satisfy the valence of carbon, this bond will be completely transferred to the oxygen. So therefore this type of reaction we call it as nucleophilic addition reaction. So for that we have this mechanism, that is addition of HCN. So here what will happen in this case, your HCN, this entire mechanism proceeds in two steps. So in the first step what will happen, the HCN in the presence of a strong base, that is OH minus, this OH minus will take this hydrogen, and this OH and this H will eliminate in the form of H2O, thereby generating a nucleophile from HCN, that is cyanide nucleophile. This is our nucleophile now. The nucleophile is ready. The nucleophile is ready to attack now. So now we are taking carbonyl carbon, which is said to be C double bond O. So this is the carbonyl carbon. Due to electronegativity difference, this will be developing positive, this will be developing partial negative charge. So the nucleophile, that is Cn minus, will go and attack to this carbonyl carbon, and what will happen, this double bond will shift on oxygen. So entire mechanism proceeds in a reversible manner. So what will happen now? So intermediate is formed. You already know in the later content we discussed, carbonyl carbon is always sp2 hybridized. So and has a planar geometry. Nucleophile can come from any direction. So what will happen, here carbon is there and here oxygen minus because of transfer of electron, and here your cyanide nucleophile has come. So now the hybridization of this carbon atom, which is already attacked by the nucleophile, so the hybridization obviously changes. Now there are 4 single bonds, therefore hybridization will become sp3. So this intermediate is unstable. So intermediate, what will happen, it will abstract a proton from the solvent, that is H plus. So where this H plus preferably goes, it obviously goes and attacks to this oxygen, because oxygen bears the negative charge there. So at the end, final product will be, so these two bonds as it is, O minus will become OH and your Cn will be as it is. So this class of compounds are also called as cyanohydranes. So since reaction is very slow, it is catalyzed by the base, that is OH minus. So therefore it is called as base catalyzed addition of HCN to the carbonyl compound. Suppose in the question paper if you get aldehyde, then here you can take R and here you can take H. So here also it will become R and here also it will become H. Here also it will become R and here also it will become H. Suppose if they give ketones, then what you will do? Instead of H here, you will take R dash. Here also instead of H you will take R dash. Here also instead of H you will take R dash. So generally I have taken without any groups, so that you find it easy for your understanding. So once Once again I repeat, the OH minus the base will take this proton, that is H, and generates the Cn minus nucleophile. This Cn minus nucleophile attacks to the carbonyl carbon, double bond shift on the oxygen and forms this intermediate. This is called as tetrahedral intermediate. Remember, this is called as a tetrahedral intermediate. Why? Because the hybridization now changes to sp3, but earlier it was sp2. After being attacked by the nucleophile, the hybridization of carbonyl carbon changes from sp2 to sp3. Means from planar triangular it becomes tetrahedral. At the end again this tetrahedral intermediate is unstable. It is immediately taken a proton to form the cyanohydrate.